Here we go. So in your notes, today's 6K, 6L. Technically, 6L is just applications. The only thing you got to learn from 6L is how to use your CAS with circular functions, making sure you put in the correct domain restrictions to get your graph and solve, and make sure that it's in radians. Other than that, you only do 6L unless you've done the previous exercises, okay? 6K though, this one you need to know. This one they always do in the exams. General solution. In your textbook, which I don't like, but I think a lot of students do like it, here's your formulas for general solution. You can use these. It's in the exam formula sheets as well. I don't recommend it because to me, you're not really truly understanding what general solution is. The idea is you're solving trigonometric equations, but without a domain. That's simply as it is, yeah? And you've already done most of that in the previous exercises. So let's have a look at this first example. Instead of using these rules, which you can memorize, up to you, I prefer you knowing how to do this. Okay, so say you got root 2 cos of x equals 1. So I've chosen a very simple equation to solve. Usually they say x is between 0 and 2 pi, right? And then you work between 0 and 2 pi up until you get all your solutions, yeah? This time, imagine I'm just rubbing that off. You do everything the same except for the end. Okay, so instead of knowing 0 to 2 pi, so this is what we do. We do the same thing, divide both sides by root 2. You get cos of x is equal to 1 on root 2. Now let's test your exact values again. To get x, I got to do cos inverse. So cos inverse of 1 on root 2, cos of what equals 1 on root 2? Adonis. Not a pi on 6. Someone else? Charlie? Pi on 4. So root 1 on root 2 is the same thing as root 2 on 2. Okay, so that's a pi on 4. So this is what we know. Here's your unit circle. Cos is positive because that's 1 on root 2. That's a positive number. The only time cos, which is the x-axis being positive, is quadrant 1, quadrant 4. So you're either up here or you're down here. And you're moving up by pi on 4 distance or down by pi on 4 distance. This is why the formula, if you look at the formula, it says plus or minus the cos inverse of A. But that's why I'm saying you don't have to memorize that rule. You just look at that. So here, I know that cos is positive in quadrant 1, quadrant 4. I know that the angle to get 1 on root 2, it has to be pi on 4 or 45 degrees. So you got these two. Now the problem is, I don't know. How many times do I have to go around this unit circle? Is it 0 to 2 pi? Is it negative pi to pi? We don't have an answer. So all you have to do now is just take any value. It doesn't matter which one. You can start like this. Shh, boys, thank you. Let's say this is 0. I would start off with 0 because that's the easiest one. 0 add pi on 4 and 0 minus pi on 4. I get two answers. I get pi on 4, negative pi on 4. But that is only one possible answer. It doesn't have to be that one. You could have done 2 pi and 2 pi. You could have said, that's 2 pi there, 2 pi plus pi on 4, 2 pi minus pi on 4, and those two are valid. There's nothing wrong with it. What you need to do now, one step, you generalize. So how do you generalize your solutions? You already know this answer here is the result of, in my case, I got pi on 4. So if that's one solution, how do you generalize for all the other solutions? You normally have to add on the period. To get back to this same point, you have to add on a full revolution. So if I started here, I'd have to go all the way around by one period to get back. So here's my first generalization. I would then say x can equal pi on 4 plus the period. Now the period of this is, there's no end there. So therefore it must be 2 pi But how many 2 pi's am I doing? Is it 1 revolution, 2 revolutions, 3 revolutions? I don't know. So therefore I do K or N, whatever letter you want to use, or whichever parameter you want to use. Okay? And then I say, where K is an element of integers, because I can go forwards, which is positive. So adding on 1 set of 2 pi's, adding 2 sets of 2 pi's, or 3 sets of 2 pi's, that's what K represents. Or it could be going backwards, minusing. Well, what I just did there is I generalized this point solution, that one. But I still have the other one to generalize as well. So if I looked at this one, to get that one, I would have started at this point, which is x equals negative pi on 4. And same thing again. How do I get all the other possible answers? You can add on the period. So here I can say plus 2 pi k, where k is an element of z, and that will cover whether you're going forwards or backwards. I get all the possible answers. That's called general solutions right there. As simple as that. So you did everything the same. Pick any 2 answers. This is my 2 answers. Pi on 4 and negative pi on 4. And you don't have to have that. You could have any other value to start off with. You just need to generalize that. So this is my 2 generalized answers. But in the exam, this is not considered 1 mark yet. If you leave your answers here, they might penalize you. Okay? And it's just part of their pedanticness. They want you to combine these 2 together. So they want you to leave your answer as a combined fraction, not as 2 terms. Okay, so that's just a little pedantic step there. But I would say if you're doing this and you're practicing it, make sure to combine them together. You're not wrong. It's just the way the examiners mark. Yeah, so the final answer, I want you to actually combine them together. So that means you have to write them out of quarters. So here would be pi on 4 plus 2 pi k times 4 over 4. Now they have the same denominators, put them all together. And you can then say it's pi, actually I'll do it a bit slower. So pi plus 8 pi k on 4. Factorize the pi and you get 1 plus 8k on 4. And then don't forget to write k element of z. That's the answer they prefer. Okay, so in your final answer, that's what I've seen. That's how they mark it. And therefore, when you do your answers, make sure to combine them together. Okay? Because that year, they might not penalize you, but then some years, if they need to find some ways to make the difference between the top end and the bottom end tails, then they might say, students who don't write in simplified form, they'll just penalize those students, and you could be one of those. Yeah? So it doesn't hurt to simplify it to this point, but it may hurt if you leave your answers here. Cool? I think their argument is to also see, because that's usually in exam 1, it's also to see how your fractions are. So your algebraic and fraction skills. That's what they're sort of looking at. All right? Other than that, that's pretty much a general solution. That's 6K. 6L is applications with your calculator. That's all really I wanted to go through. You can go through the notes from your textbook and then follow with your calculator. That's for 6L, and that finishes up chapter 6. So chapter 6, the main part was exact value symmetry properties. Next core is sketching, because you can sketch means you can find solutions. And then finally, if you can find solutions, general solutions. And every chapter has an application. So it's the same thing over and over. Cool. Next week, we're probably starting on chapter 7. And remember, chapter 7 is a breather. It's a time for you to, it's really just going through chapter 1, functions again. So if you needed time to catch up, that's a good time to catch up. Because right after chapter 7, it's calculus. As soon as you finish calculus, it's pretty much sack time. Okay, so try to keep up. If you got a bit of a breather for chapter 7, if you didn't learn chapter 1 well after this sack, that's a time to learn your chapter 1 again. Okay? All right, Tim, I'm going to stop the video there.